On to Chapter 3 questions from an introduction to statistical learning, starting with the conceptual questions, and question 1 is right here. So, describe the null hypotheses to which the p-values given in table 3.4 correspond. Okay, so and I've recreated table 3.4 right here. Explain what conclusions you can draw based on these p-values. Your explanation should be phrased in terms of sales, TV, radio, and newspaper, which were the terms in this analysis, rather than in terms of the coefficients of the linear model. And so here's the coefficients. Okay, so let's talk through this a little bit. So like I said, I've recreated table 3.4, and what's important to realize, if you're not sure, is that these values came from a multiple linear regression from earlier in the chapter. That's what. So this chapter is all about linear regression, and this is from multiple linear regression, which means that we have several, that we are using several explanatory variables to explain, in this case, sales. Okay. So let's go through and describe what the null hypotheses would be for each of these terms. Okay, so it probably helps to understand what a null hypothesis is, and I've kind of given a little blurb here to kind of talk about it. But in my mind, it is something like this. This won't be true to the letter, but I think it's helpful. So when we are doing null hypothesis significance testing, which is what we're doing here when we're trying to find p-values for these different terms, what we do is we try to detail what we think what the probability distribution of the outcome variable would be if it was not related to the explanatory variable that we're interested in. Okay. So let me say that again. We want to detail what the probability distribution of values would be for an outcome variable if that outcome variable was not related to a particular explanatory variable. Okay? And so we would call this, or I call this, the null distribution. And the null hypothesis is just simply that the null distribution accurately describes the data. Okay? And so if that is the case, if it does accurately describe the data, and we get to decide what accurate is accurate enough, and if it does, we tend to retain the null hypothesis. But if it does not, we reject the null hypothesis. And so when we are rejecting the null hypothesis, what we are saying is that that explanatory variable is related to the outcome. And when we retain the null hypothesis, we are retaining the position that it does not seem that the explanatory variable is related to the outcome variable. Okay, so we could phrase an explanation for each of these p-values like this. So after accounting for blah blah blah, there is no association between sales and blank. Okay, so if we're considering television, if we're considering TV, after accounting for radio, newspaper, as well as the intercept, or just the average value once everything else is being accounted for, just the average value of what we think sales would be without any input from anything, there is no association between sales and TV. So that would be a statement of null hypothesis. Okay. So now when we run the significance test and we come up with a conclusion based on the p-values, we can also phrase this in terms of a generic script. Okay? So after accounting for blah, 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 the null hypothesis that the association between sales and blank, being due to chance, or being well described by the null distribution, be another way of saying that, is blank percent probable. Okay? So again, looking at television, looking at the term for television here, okay, we would say, after accounting for radio, newspaper, and the intercept, again, which is just the average value of sales regardless of anything else that may be affecting sales, okay, the null hypothesis that the association between sales and TV being due to chance is less than 0.0001% probable. Okay? So this presumably passes some kind of threshold in your mind for the null hypothesis being very unlikely. And so in that situation, we would tend to reject it and instead believe that, that television advertising does somehow affect sales. Okay? Well, how much does it affect sales? And so that's where the rest, well, where some of these other terms come into play. So the coefficient here is basically the value by which we think that sales are being increased by TV advertising. So for every unit of TV advertising, sales are going up by 0.046 units of sales. Okay, that's it for this.